You've already discovered this information, so just to review a little bit, inverse functions from our exploration activity, you notice that the graphs of inverses are reflected across the y equals x line, or at least you might have seen something like that. Also, you would have seen that the x and y ordered pairs of the functions are switched on the inverses. So if the ordered pair of the original function was 1, 2, the inverse would be 2, 1 at that same point. What you did not see is how, when you are given a function, you can find its inverse. And that's basically what I'm going to teach you in this lesson. Okay, to find the inverse of each function, it basically is asking us it's asking us find the inverse of each function and then is the inverse a function. So in problem 1 here on the left, it says f of x equals 3x plus 1. We know it's a function. So to find the inverse, you need to switch the x and the y and then solve the equation for y. You might say, well, hold on, where's the y? Remember back in like chapter 1, we discussed if you have f of x, it's the same thing as y. So basically that function is y equals 3x plus 1. The x and the y variables you switch, so it's going to turn into x equals 3y plus 1, and you solve that equation for y. Subtract the 1, divide by 3, you get x minus 1 divided by 3. Is that inverse a function? To determine functions, we graph them and see if it passes the vertical line test. So in this case, yes, it is a function because it passes the vertical line test. Okay, for question 2. Find the inverse of that function and is the inverse a function as well. The function is f of x equals x squared plus 4. So to find the inverse, switch the x and the y ordered pairs or variables. So we'll get x equals y squared plus 4. Solve for y, subtract the 4. And then we have to square root. Remember, we don't know for that variable y, we don't know if we're squaring a positive or a negative number. So when we square root, we'll get positive and negative. The square root of x minus 4 equals y. And to graph that, you actually have to use two separate lines. You have to graph a positive square root of x minus 4 and a negative square root of x minus 4. That's why you'll see in my graph it's two separate colors. We have green and blue, red and blue. But again, the only reason we're graphing it is to determine if that function passes the vertical line test, which it does not. So the inverse of the quadratic function is not a function. Okay, for each of these, we have to find the inverse. That's what this find f to the negative first power means, find the inverse. Find the domain and range of the original function and the inverse, and then determine whether the inverse function is a function, or the inverse is a function. So for number 3, f of x equals 3x plus 4. To find the inverse, switch the x and the y. So we'll have x equals 3y plus 4. Solve for y, subtract the 4, divide by 3, so y equals x minus 4 divided by 3. That graph is to the right here. It is linear. It passes the vertical line test, therefore it is a function. So then from here we just need to identify the domain and range of both the original function and the inverse function. So because they're both lines, it's kind of hard to determine or see how the domain and range are interchanged here. But again, because it's linear, the domain of our original function is all real numbers, and so is the range. And then same for our inverse function, because it's a line, the domain and range are both all real numbers, which can all be written as negative infinity to positive infinity as well, as an ordered pair instead of all real numbers. The important one I want to pay attention to is here's 4. So find the inverse. All right, so we will switch that up, and it'll be x equals the square root of y plus 7. Now this is important here, and I don't have it written. Since x equals a principal square root, since x equals a square root, we have to only look at values of x that are bigger than 0, because we know real numbers, we can't take the square root of negatives. So here we have to take a mental note that x is bigger than or equal to 0. And we can go through it and continue to solve. So we'll have square both sides, x squared equals y plus 7, so y equals x squared minus 7. The domain of the original function is negative 7 to infinity, negative 7 to infinity. The range is 0 to infinity, which if you graph that, you will be able to see that very clearly. And then this is kind of where you can see how the domain and range are interchanged then here. So the domain of our inverse function is going to be the range of our function 0 to infinity. You might say, well, that doesn't match up, but it does where x is greater than or equal to 0, which would be on that y-axis here. Actually, that y-intercept is 0, -7. So from there up is where it matches our domain, because again, we're only looking at values of x that are bigger than 0. And then the range is the domain of our original, -7 to infinity. As you can see, again, because our y-intercept is 0, -7, that whole parabola graph is above that. So again, -7 to infinity there for your range. Okay, so in summary here, we need to answer these questions. First of all, what are inverse functions? There's a lot of different ways you could answer that. You could say they are functions that are reflected about the y equals x line. You could say they are functions whose domain and range are interchanged, whose x and y coordinates are interchanged. There's a lot of different ways you could answer that part of the question. How can you find an inverse function? Remember, switch the x and the y values and then solve the equation for y. And then if we have the domain of the original function will be the blank of the inverse function. And hopefully when you read that, you said range, because the domain of the original function will be the range of the inverse function.